Welcome to the Explainer. Today, we're going to do something fun. We're stepping right into the shoes of an AWS Solutions Architect to see exactly how they tackle real-world challenges, one problem at a time.
All right, so let's just dive right in. I mean, we've all seen the job title, right? But what does it actually mean? Let's get past the buzzwords. What are the complex, high-stakes problems they're really solving every single day? Let's find out. Okay, before we get into the real nitty-gritty stuff, we've got to start with their core mission. It's so important to get this right. It's not just about the tech.
So here's the key thing to get. They live right at that intersection of business and technology. Think of them as translators. They take a business problem, say, we need to cut costs, or our site has to be more reliable, and they design the technical blueprint in AWS to make it a reality. They're basically master puzzle solvers. And AWS, well, that's their giant box of puzzle pieces. All right, let's jump into our first challenge. And this one is always, and I really mean always, the top priority for any architect worth their salt: security. I mean, you can build the fastest, most incredible application in the world, but if it's not secure, it's pretty much worthless. Okay, so here's a classic situation, something you see constantly. Your test team, right? They need to check something in the live production environment. So how do you give them that access? Temporary, limited access without, just handing over the keys to the king. And wow, you can really see the difference in thinking here. The wrong way? Well, it creates permanent gaping holes. Making duplicate users, that's just a nightmare to manage. And sharing permanent access keys, that's like security sin number one. The right approach, on the other hand, is just so much more elegant and secure. This is just a perfect example of that principle of least privilege we hear about. The role is kind of like a temporary security badge. The person from the test account assumes the role, and they get a set of temporary credentials, keys that only work for a little while and can only do very specific things. And when they're done, poof, that access just evaporates. It's secure, you can track it, and it's clean. All right, on to the next security puzzle, and this one's also super common. It's not always about people needing access. Sometimes our own systems need to talk to each other. So how do you let your application, running on a server, securely talk to, say, your file storage in an S3 bucket? Okay, rule number one, the absolute golden rule here, is you never, ever store permanent credentials on a server or hardcode them into your application. Just don't do it. Why? Because if that server ever gets compromised, the attacker has the keys. They have everything. It's a huge and totally avoidable risk.
So if you take away one thing from this security section, let it be this: roles are the answer. For people, for applications, for everything. They let your resources get those secure temporary credentials to talk to other AWS services, and you never have to deal with managing secret keys. It's absolutely foundational to how you do security right in AWS.
Okay, so our fortress is secure. That's step one. Now let's switch gears and see how an architect thinks about building systems that don't just work. We're talking about systems that can handle massive traffic spikes and, this is the critical part, can survive when things inevitably go wrong. Picture this. It's the 3 a.m. phone call that every single person in operations dreads. The database, the very heart of your application, is down. It's a nightmare scenario. But a good architect has already thought about this. They've planned for this exact moment and built a system that knows what to do. This right here, this is exactly what we mean when we say design for failure. With a multi-AZ database, AWS is keeping a live, perfectly synced copy of your database in a completely separate physical data center. So when the main one fails, AWS just automatically flips a switch. And the best part, your application doesn't even know. The address it talks to stays the same, it just points to the new database. And you're back up and running in minutes, usually without anyone having to lift a finger. Okay, so let's take that same idea and blow it up to cover the entire application. Because it's not just about one piece failing, right? It's about building a whole system that can handle failures and those crazy traffic spikes without breaking a sweat. So what does that recipe look like? This is pretty much the classic recipe for high availability on AWS. You've got the elastic load balancer acting as the traffic cop, directing cars where to go. Then there is the auto-scaling group. That's the manager who can hire more servers when it gets busy and let them go when it's quiet.
Spreading all of this across multiple availability zones protects you if an entire data center has a bad day. And of course, that multi-AZ database we just talked about holds down the fort for your data. Put it all together, you get a resilient, self-healing system.
And hey, here's a quick little pro tip every architect has to keep in their back pocket. You know elastic IPs, those static public IP addresses? By default, you only get 5 of them per region. 5. It sounds like such a small detail, but trust me, it's a critical little piece of information you absolutely have to plan for when you're designing your architecture. All right, next up, let's tackle a challenge that is just exploding everywhere these days. How do you make sense of massive, and I mean enormous, amounts of data without completely blowing your budget? And this is such a perfect example of an architect solving a business problem. See, the issue isn't just we need to analyze data. The real problem is our current way of doing this is costing us a fortune. The architect's job here is to step in and find a smarter, more cost-effective technical fix. And very often, that solution is Amazon Redshift. Now, the magic behind its speed really boils down to 2 things: columnar storage and parallel processing. So, unlike a regular database that stores data in rows, like a spreadsheet, Redshift stores it in columns. For the kind of big analytical questions you're asking, this is just way, way faster. Then, it takes your question and breaks it up, running it across a whole cluster of computers at the same time. The result? You get answers in seconds, not hours. So for the business, the value here is just crystal clear. They get to run all these heavy data crunching jobs without slowing down their main application that customers are using. That's huge. And they do it with a service that's fully managed by AWS, which is often dramatically cheaper than their old solution. It's a win-win-win. So we've looked at some specific tools, some specific challenges, but what's the real big picture here? What's the takeaway? The true value of a great solutions architect, it isn't just knowing what all the services are called. It's about a mindset, a way of thinking. This list right here, this is the heart of it. It's a mindset that always, always starts with security. It assumes things are going to break, so you build systems that can heal themselves. It's about automating everything you can to avoid manual mistakes. And most importantly, it's about tying every single technical decision back to a business goal. Every choice is a trade-off between things like cost, speed, and reliability. And a great architect, they're a master at finding that perfect balance for the problem at hand. And really, that's the ultimate challenge, isn't it? It's one thing to memorize what a service does. Anyone can do that. But the real skill, the art of it, is looking at a business problem and knowing the right questions to ask to design the perfect solution. It's not about knowing the what. It's about deeply, truly understanding the why.